Hello everyone. So today we're going to do a topic explaining a topic for 2 degrees of freedom systems, and the way we're going to counter that is by describing a system and derive the equations of motion for it, and then we're going to do all sorts of doing the frequency matrix and then doing the shape modes of the system, and let's get down to it. So we've got a system here of two masses, so they're connected. Let's go with blue. We've got a system of masses. They're connected by a spring and to the wall. There's a base here. That's the wall, and there's mass 1, and that's mass 2, basically. And sorry, there's a spring here. Now, so then, this is the direction of motion. Okay, so the first step that you should do in order to derive the equations of motion, number one is draw the free body diagram of the first mass. So step one, the free body diagram of mass, of each mass. Let's say that. So then we've got mass 1 here, M1, and we've got force acting there in tension, and got another force acting in tension here. Now that's F spring number 1. That's going to be K1 times X1, and then we're going to have FS2, and that's going to be K2 times the displacement, which is basically X2 minus X1. And if we draw the free body diagram of mass 2, the force here, Fs3, is going to be basically the same thing as Fs2. Okay. Now you've got the free body diagram of mass 1 and mass 2 of each mass, and now what we're going to do is basically get the equations of motion. And the equations of motion, we've talked about this earlier. When you're doing translation problems, all you have to do is take the sum of the forces. Then we're going to take the sum of forces. So we take the sum of forces equals to mx dot dot. The x dot dot is basically the acceleration. So then for mass 1, we're going to do that for mass 1. So the first force, and then we're going to set a direction. So downwards is positive. So then negative Fs1, positive Fs2. Okay, let's go to the next page and elaborate more. So m1 x double dot 1 equals to k1 x1, that's the negative there, plus k2 x2 minus x1. Let's solve the equation of motion. So m1, let's bring everything to this side here. It's going to be positive. It's going to be negative there. K2 x2 minus x1 equal to 0. And now let's group similar terms together. Plus, so k1, and then positive k2, because the minus and the minus will cancel out. So we're going to have plus k2 x1, and then minus k2 x2 alone. So that's equation 1, basically. Now let's do system 2. If we do system 2, do another color here. for mass 2 we do the same thing. So sum of forces, mx, so, and downward direction is going to be positive. So I'm going to say m2 x double dot 2 equals to negative k2 x2 minus x1. m2 x2 positive k2 x2 minus x1 equal to 0. Let's go to the other page here, and that's going to be m2 x2 to x double dot, sorry, plus, so k2 here is positive, so plus k2 x 2 negative k1 x1 equal to 0. Let's double check that for a second here. That's absolutely correct. So that's equation 2. So now what we're going to do is we're going to solve these two sets of problems. And the way to do that is very simple. All we're going to do is assume the solution. Assume the harmonic solution. And that's basically xi equals to xi cos omega t plus phi I. Now, and we're going to basically sub this equation here into these two equations and solve. So let's go and do that. Okay? So let's use, what color should we use? Let's use this color here. Okay, so x of t equals x cos omega t plus phi, and we're going to do x dot x of t, that's going to be a negative x omega sine omega t plus phi, and then we're going to do the x double dot. Let's put t here. Let's just fix that really quick here. X, actually, you know what, let me just do it here. So x t minus omega squared x cos omega t plus phi. Now let's sub in this here and this here into our equation of motion. And that's exactly what we're going to do. So we have, so right here, first equation of motion here is this here. I'm going to take that there, copy and go, and then paste it here. Okay, so M1, open brackets, and sub in. Actually, let me just go back to this color here, just to keep things consistent. And omega squared x cos t plus phi. Oh, sorry. And back. And that's going to be plus k1 plus k2 x1. We're going to go back. Yeah, this is x1. Forgot to put the one here. Put the one there. And then it's going to be x1 cos omega t plus phi. And then negative, let's do back. Let's go negative k. That's supposed to be k2. Is it right? Yeah, that's right. Forgot to put the q there. So k2 that's going to be x 2. See that's x2, that's x1, so just watch out for that. Now we can solve this equation. So basically this term right here, this term, it's common. So I'm going to take that, throw it out of the equation, and we'll end up with a clean equation. We'll end up basically with x1, that's going to be m1 negative, oh sorry, let's do that again. And we're going to end up with negative omega squared m plus k1 plus k2 x1 negative k2 x2 equal to 0. So that's number 1. And let's do the same process again for equation 2. I'm going to cut it short here and do another video on that, so you can watch part 2. And thanks and see you in part 2.